Hello and welcome to Woven Chemistry. I'm Jean Weaver, and today we're going to talk about limiting reactants, and this is part 2 of a 4-part series. Well, if you can't tell, it's a nice evening here in Wisconsin, and so I'm going to give a try to recording this outside. So hope you don't mind the birds in the background, and we might get a few fireworks. We'll see. But what we're going to do differently in this video compared to the last is that we're going to take the same reaction, but we're going to use different quantities of the base and the acid. So that will set us up to have one limiting reactant and one excess. Okay, so let's get started. Here's our reaction, and let's take 20 mils of the acid and 80 mils of the base. So obviously we'll get about 100 milliliters of product, but this time it's going to be a little bit trickier to figure out what the concentration or how many moles of that salt we're going to produce. So here we have, just to review, the symbolic representation of this reaction as well as the macroscopic perspective. And what we're going to do first is illustrate this reaction at the microscopic level. So just like last time, I'd like you to draw the microscopic or the particulate representation of this reaction in these beakers. But so that we can compare our answers a little bit more easily, let's all use one HCl in this first beaker, and then do everything else accordingly and to scale. Okay, so as always, get out a sheet of paper, pause the video, sketch out your answer, and then come on back when you're finished. Okay, so welcome back. Okay, like I said, we're going to have one HCl. That's a strong acid that splits itself up completely in water. So we'll have a hydrogen ion and a chloride ion. Make sure that you have the charges. If they weren't charged, then they wouldn't dissolve in water. Okay, we've got 80 milliliters of base and only 20 of acid, so 4 times as much base. So we should have 4 sodium ions and 4 hydroxide ions. All of them separate, not touching each other, and charges on everything. Okay, so figuring out the product, that chloride will react with that sodium. We should have 1 sodium chloride, and these should not be touching. They're not going to bond because sodium is an alkali, and alkalis are always soluble in water. Okay, the hydrogen ion will bond up with the hydroxide to make water. And just like I said in part 1, when water is formed, it's made of atoms, not ions, so make sure you don't have any charges here. Okay, now let's cross off what we've already used, and we see that we don't have any more reactant, and we've got plenty of base left over. So we've got the 3 sodium and the 3 hydroxide left over. And so what this means is that the hydrochloric acid is the limiting reactant because the reaction stops when we run out of these, and the NaOH is in excess. And we can see that because there's leftover here with the product. Okay, now what about the colors? Well, the reactant is acid, so the universal indicator would look red. The second beaker contains a base, so that one would look blue. And the product, I don't see any red hydrogen ion here, but there's plenty of leftover hydroxide, so the product beaker would appear blue. Okay, so just as a review, here's our macroscopic, obviously missing the universal indicator, our symbolic, and our microscopic perspective of this reaction. Okay, so now let's graph this situation. So please graph the moles versus time of all 4 substances in this reaction. And I really recommend that you set yourself up with a little table of what we have to start of each of these things and what we have to finish. And obviously everything should be in the form of moles so that we can easily graph it. Okay, so once again, pause the video, sketch out your answers, and then come on back when you're finished. Okay, welcome back. All right, so for the reactants, if you use this formula, you find that you get 0.02 moles of the acid and 0.08, or 4 times as much, of the base. And because the reaction hasn't done anything yet, we have no product. Okay, so we need to figure out how much we're going to use of each of these reactants. Well, how much you use is dependent on the limiting reactant. And we're going to use it all. We saw that in the pictures, so we'll use all of the 0.02. How much of the sodium hydroxide is used? Well, again, they have this 1-to-1 invisible reaction ratio, so that means we're going to use 0.02 moles of the base. How much product is formed? Well, we look again at that reaction ratio, and it's 1-to-1 for everything. So we will make 0.02 moles of the base. Now it's really important, not of the base, 0.02 moles of the products. And please make sure that you distinguish that we use reactants and we make the products. All right, so now let's figure out what we have to finish. Well, as in the pictures, we have no acid left over. And if we use 0.02 and we started with 0.08, well, we're going to end up with 0.06 of the base, and we'll end up with 0.02 of the products. All right, so if you don't have the same numbers as I have, then it's probably a good idea to pause the video and re-sketch out your graph so that we can compare a little better. So moving on with the graph, here are the numbers for the y-axis. Let's assume that I'm going to use these colors for each of the substances, and let's assume that the reaction is going to stop right here. Starting with the acid, it starts at 0.02 and drops to 0 because it's the limiting reactant. The base will start at 0.08 and end up at 0.06. And notice that both of these lines plateau at the same spot. They plateau when the reaction stops, which is when we run out of HCl. Another thing to note is that these red and blue lines are parallel. Okay, they have the same slope because the reaction coefficient is the same for both. Now with the products, we're going to start at 0 and end up at 0.02 for both of them. So we should have a green line for water and a yellow line for salt that go just like that. Notice they also plateau when the reaction stops. And one more thing to notice, if we were to calculate the slope of the green and yellow lines, it would be the same but opposite of the red and blue lines. And again, that's because our reaction coefficients are 1-to-1-to-1. And one last thing, let's link this back with our drawing that we had. This was our product beaker from earlier. And we see that there's no water here. There's no acid, which is consistent with this line going to 0. There's one salt and there's the one water. So these lines end up at the same place. And we see that there's quite a bit more sodium hydroxide, and that's why the blue line ends up higher. Okay, so again, it's really important as you're studying chemistry to be able to link this symbolic, the macroscopic, the microscopic, and this graph all together. If you can really understand it and see it in these ways, it's going to make chemistry a whole lot easier for you. Now let's take this one step farther, and let's say we've got this product beaker, and what would happen, or would we make more salt if we added more HCl, or if we added more NaOH to the products of this previous reaction? Well, if we think about the HCl needs sodium hydroxide to react. And lo and behold, here's some sodium hydroxide that the equation says we need. So if we add more HCl, the reaction would proceed and we would make more sodium chloride. Now what about if we add base? Well, the reaction says that we need HCl to react with the base. But there is no HCl. There's chloride, but there isn't any hydrogen ion. You need to have both. So this reaction wouldn't happen, and there wouldn't be any more NaCl formed. Okay, so I hope you've enjoyed that. I hope you've learned at least a little bit from that. And I really encourage you to come back and watch part 3. This one's going to be another step higher in terms of challenge and complexity, because we're going to use a diprotic acid instead of HCl, a monoprotic acid. That makes things more complicated for 2 reasons. We get a 2-to-1 reaction ratio, and part of this acid is strong and part of it is weak. So that will make things a little bit more challenging. This is often a confusion at the AP level. Okay, so thanks a lot for joining me, and hope to see you again.